Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today I would like to teach a concept called basic gates. In the previous lecture I told you what are the available 7 gates and what are the basic gates and what are the universal gates and general gates. Now let me explain each and every individual gate briefly. What are its characteristics and what are the properties we are going to learn. Now let me take upon a concept called NOT gate. We can say here basic gates, basic logic gates. I can say basic logic gates. Basically we have 3 basic logic gates. First one is NOT gate, and second one is AND gate, and third one is OR gate. Sir, let me take NOT gate first, and I would like to explain briefly how it works when we take a switch circuit and when we take a transistor circuit, how it works. Let me explain NOT gate first, and then we will see AND gate and OR gate. First of all, NOT gate. Sir, the moment when I start to teach a basic gate or any logic gate, I would like to remember the point. I would like to remember the points are what is first thing is what is its logic circuit. What is its logic circuit? And what is logical expression? How many number of inputs and outputs? We can say fourth one is truth table, and then fifth one is its properties, or we can say characteristics. Let us try to understand all these things. Sir, NOT gate is a basic gate. The logical circuit of NOT gate we have already seen in the previous lecture. This is what we know, that this is a diode. Basically when we connect here bubble, automatically it will act as a NOT gate. Here this is called logical circuit symbol, NOT gate. Here input is A. Now output is Y equal to A bar, because it is acting as complementing or opposite, or we can say here this is acting as a complement gate. So that's why I want to call it as complement gate, or also called as complement. Complement gate. Now next, logical expression. This is called logical expression, Y equal to A bar. And now coming to number of inputs, sir. Here number of inputs are 1, and then number of output is also 1. We can say number of inputs here is 1 and number of outputs also 1. And after that, here we need to see what is the truth table. Sir, let us try to understand. Here NOT gate having only one input. I told you in the previous lecture to calculate number of inputs, we just need to take one equation called 2 power n. Here n is number of inputs. So let me take this equation 2 power n. Here for NOT gate number of inputs is 1, so A equal to 1. So let me take n equal to 1, 2 power 1 equal to 2 inputs, 2 input combinations. We can say. So what are those 2 input combinations, sir? Sir, we can say one is 0 and another one is 1. Here input, and now output here I can write y equal to a bar. Here input is a. So now let me take one truth table for this particular NOT gate, sir. When I give a equal to 0, we can say a equal to, when I give a equal to 0, what will happen? When I substitute here 0, automatically it will complement, it will get opposite, because here it is acting as a NOT operation. So output will be 1. And now when I give a equal to 1, automatically output will become 0. This is called truth table of NOT gate. And we need to see the properties of NOT gate. Let us try to understand. Sir, basically this is a gate. This is a gate. You can say NOT gate. This is a NOT gate. The moment when I connect another gate here, when I connect another NOT gate here, now if I connect the feedback to back input, here I took two NOT gates and I connected feedback output to input. Now let me try to apply as a input a equal to 0, a equal to 1 or a equal to 1 I applied. So the output of first gate will become, this is first gate and second gate, output of first gate is 0. And after that, when I give this 0 to immediate second gate, automatically I'll get output is 1. So what I am trying to say here, when we connect even number of gates, of course the NOT gate circuit, entire NOT gate circuit is acting as like a buffer, or we can say memory element after some delay. Suppose when I apply a equal to 1 here, this 1 will become a 0 after some delay, because this NOT gate performing complement operation, and after some delay it will goes to second gate input, and after some delay even second gate also producing another output. Which means what I am trying to tell here, sir, the input to a equal to 1 we are giving, after some delay we can say fixed delay, of course 1 nanosecond we can say for NOT gate, and then same 1 nanosecond it will take second NOT gate. After 2 nanoseconds output is even 1. We can say the circuit is acting as a we can say buffer or a memory element. And then let me take another example here. Here, sir, if I can connect only one NOT gate, or we can say 3 NOT gates. If I can connect 3 NOT gates, and I want to take feedback again. Here again I am giving a equal to 1, and now this is what output y equal to a bar we can say. So what is the output, sir? When I give a equal to this particular NOT gate 1, output is 0, and then if I can apply this 0 to second NOT gate, output is 1, and then if I can apply this 1 to third NOT gate, output is 0. And now this 0 will become coming back to feedback to the first NOT gate. Sir, the moment when I connect even number of NOT gates, the circuit is acting as a buffer. We can say acting as buffer, or also we can say memory element. But coming to this 3 odd number of NOT gates, when we connect odd number of NOT gates, circuit behaving in different way. Here it can act as a sir, complement circuit. First thing, it can act as a complement circuit, and now I can also call as the circuit is acting as a square wave generator. How, sir? Let me explain. Square wave generator. Let us try to understand. Here 1 is given, which means the circuit wave is like this, and it is producing output as 0, which means for some delay the output will become stay in low stage. We can say 0 voltage, and after some time the output is becoming as 1. We can say it will become 1. We can say positive level, and now output is becoming as 0. We can say negative level. What I am trying to say, is it not a square wave? Yes, sir. When we connect a odd number of NOT gates for a NOT gate circuit, we can expect the output is in the form of square wave. So I can say that this is called a square wave generator, and also we can call it as a stable multi-vibrator. A stable multi-vibrator, because only one state is stable, sir. Here this is 0, and now this is 1, and now this is 0. We can say one state is, we can say one gate is stable and another gate is unstable. Oh, so after one by one the gate is stable, unstable, so that only we can say that a stable multi-vibrator means only one stable state is stable and remaining other state is stable. So we can call it as a stable multi-vibrator. After understanding about all these things, let me explain one more thing, how NOT gate connect as a transistor circuit, or how NOT gate connect as a switch circuit. Let us try to understand. Sir, this is a switch circuit. We can say that, this is A, and now Y equal to A bar output. Let me connect here one switch. This is, we can say, ground, and now this is switch A. So to understand this operation, let me take one more circuit here, transistor circuit, NOT gate as a transistor circuit. So let me take one transistor here. This is one transistor. You know that. Let me connect here one resistor. We can say base resistor, and this is input A. Now here power supply plus VCC collector control voltage, and here RC collector resistor, and now this is, you know, that emitter, and now I will directly connect it to ground. Here I want to take output Y equal to A bar. Sir, let me try to explain with a truth table. Here A is input, and now transistor state, we can say transistor state, and output Y equal to A bar. Let me take this example. We know that for NOT gate we have two inputs, one is 0 and another one is 1. Now sir, here I want to apply A equal to 0. The moment when I apply A equal to 0, here plus VCC equal to we can say plus 5 volts. The moment when I apply A equal to 0, here sir, the required input voltage for the transistor to turn on, we can say 0.47 volts. Here we are applying input as 0, so that based upon this voltage, input voltage, transistor cannot turn on. So the moment when transistor is off state, we can say transistor is off state, and we are giving A is 0. Automatically we can say that there is no connection between plus VCC and transistor. And now whatever the input we are applying, whatever the input supply we are applying VCC, it will directly goes to output. Plus VCC, it will directly goes to output. So we can say that Y equal to A bar, we can say Y equal to 1. So because the total power supply, whatever we are giving here plus VCC, it is directly going to output, so that we can say output will be 1. And now let me take A equal to 1. The moment when I apply A equal to 1, here the required input voltage for the transistor to turn on, we can say 0.47 volts. Here we are applying more than 0.47 volts. So A equal to 1, automatically transistor turns on. The moment when transistor is turning on, the input supply, whatever we are applying here, plus VCC, plus 5 volts, it will comes directly from plus VCC to through RC, and then it will goes to we can say that through transistor it will goes to ground. So now here transistor is turning up, and now whatever the power supply we are giving, it is directly going to ground. So output we can say plus VCC is not at all going to output, so we can expect output Y equal to 0, because plus VCC, because transistor is turns on and then there is a connection between ground and source, so whatever the apply input voltage we are giving here, it will comes directly towards ground, so output we can say Y equal to 0. So the moment when transistor is on, automatically plus VCC is going to ground, so we can expect output is 0. So what I am trying to tell you here is, based upon this truth table, the moment when I give input is 0, A equal to 0, output is 1. And now the moment when I give input A equal to 1, output is 0. So this is how we can understand NOT gate operation with the help of transistor, and we can with the help of switch circuit. So these are the properties of NOT gate. And now let us see another gate called AND gate. Thanks for watching. Please do subscribe.